Hey guys, welcome. It is part 2 of our study guide, and we finished part 1. Let's go on to part 2. Alright, given the triangle below, use the law of sines to solve for x. So if you recall, the way we want to do this, we want to start with the angle here on the very far side, the cosine of 113, and over here we're going to do x squared. And the rest we can just fill in pretty easily. So they're the remaining sides. So 29 squared, we're going to get plus 21 squared minus, and then we're going to get 2 times 29 times 21 times cosine. Okay? So the way I like to do this is I like to solve this part first, and then all of that part second. Okay? So in our calculator, 29 squared plus 21 squared is going to give us 1282. Again, that's a subtraction sign. 2 times 29 times 21 times the cosine of 113. So just in case you didn't know what that looked like in my calculator, that's what it looks like there. Enter. And it has a negative already, so I need to write that. 475.91, 05145, so on and so forth. So two negatives do make a positive, so I'm actually going to end up adding these together. I'm going to go ahead and just write 1282 minus my answer. It's actually going to add it together for me automatically, because it understands that two negatives make a positive. And then I'm going to take the square root, and I just have to hit the square root of the answer, and we have 41.92, which I'll round to 41.93 for x. Okay. All right, 26. Find the measure of one exterior angle. Well, remember the sum of exterior angles is going to be 360 every time. So if you want to know what one of them is, well, there's 42 of them, so you just divide by 42. And we have a pretty simplistic answer of 8.57. Again, rounding to the hundredths place here. Find the measure of one interior angle. Well, the interesting thing, if you take any shape, okay, here would be the exterior angle, here's the interior angle, those two are going to add up to 180. So if I find the exterior angle, which would be 360 divided by 32, which is 11.25, all I have to do is subtract that from 180, and I'm going to come up with my answer. And in this case, I come up with 168.75 degrees. The sum of the interior angles. So the sum of the interior angles is given to us by the formula 180 n minus 2. And n stands for the number of sides, so we could just do 180 28 minus 2, which is going to be 180 times 26, which is 4,680 degrees. The sum of the exterior angles, well, that's the same. Doesn't matter what shape it is always 360. The sum of the interior angles of a regular polygon is 2,340. How many sides does it have? Well, if I know the formula, I can just set it equal to the formula. So I can divide by, sorry, it's not n minus 2. It's n minus, no, it is n minus 2, I think. Let me double check. I'm pretty sure n minus 2, I apologize. Okay, yeah, sorry. This is correct. Here we go. Divide by 180 first, actually. So 2340 divided by 180. So we get n minus 2 equals 13, add 2 over, and we get 15 as our n. That's how many sides we have. The measure of one interior angle of a regular polygon is 165. How many sides does it have? Well, if the interior angle is 165, then the exterior angle, we know, is going to add to 180. So we basically know that we're dealing with 15 degrees here. And if we have 15 degrees as the exterior angle, we want to say, how many times does that fit into 360? So we could divide that into it. And that should tell us how many sides we have, which is 24 sides. The measure of one exterior angle of a regular polygon is 12. How many sides does the polygon have? This one's pretty easy. We just do 360 divided by 12. This time, How many times does it fit in? 30 different times. And that would give us our answer. Like this section is going by pretty quickly. Alright, find the area of the figure below. Don't mind if I do. I'm just going to go ahead and cut that off right there. This is going to be 12 times 9. And we get 108. Okay, over here we want to go ahead and find this measure right here. So we're going to do 12 away from 21. So we take that 21, take 12 away, and we get 9. So this length is 9. So we do 9 times 13, 117. Add them together. We get 225. So this is a composite figure, so we basically just try and break it up into shapes that we know how to find the area of. Alright, find the area of the parallelogram. We're looking for a 90 degree now. Unfortunately, this is not a great picture, but we want to, we would hopefully have a 90 degree right here. That's what we should have. It doesn't have that here, but it should be there. So we want to do parallelogram. The area is going to be b times h, base times height. So here's our base of 12. Oops, I put that in the wrong spot. And our height is 8, so b and h. There we go. 12 times 8, and we get 96. Again, we're talking about areas, so I should be putting on units squared. Okay? Or sorry, square units. Find the area of a regular heptagon. The apothem is approximately 5.58 inches, and each side is 14. So first of all, a heptagon is 7 sides. And our formula for this was 1/2 a times p. That p is a perimeter. So the perimeter is going to be 7 sides times the length of 14. Since it's regular, they're all the same length. So we get 98 for our apothem. Perimeter, and our apothem is 5.58. We can just multiply all this together. And there we go. If we do that all correctly, we should get 273.42. And that's going to be in centimeters squared. Square centimeters. I keep saying it wrong, dang it. Find the area of the triangle below. Well, again, I'm sorry, but that is supposed to have a 90 degree on it. Otherwise, we'd have a difficult time. But triangles are 1/2 base times height. So 1/2, 25 times 14. And we can just do our math real quick, and we are all set. 175, and we're going to do square units. Find the area of a regular hexagon with a side length equal to 8. Leave an exact form. Right, hexagon is 6 sides. So boom, 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 boom. This is one of our side. Side length is equal to 8. Now remember, there's 6 pieces, so it cuts 360. We're finding that central angle. So 360 divided by 6 is going to give us 60 degrees in here. We're going to cut it in half. That's going to leave me with a 30, 60, 90. Okay? This is going to cut this in half into 4 and 4. So this is 4. And then across from this is going to be 4 rad 3. So there's our apothem. So we have the apothem at 4 rad 3. Our perimeter is going to be 8 times 6, which is 48, I believe. And we just throw in our formula, 1/2 4 rad 3 times 48. It says leave in simplest radical form, so that's what we will want to do. Alright, multiply it all together. It says leave an exact form, that's why I left it with the rad 3. If you leave it as a decimal, it is not in exact form. Okay, so exact form means no decimals. Alright, moving on. Find the area of a trapezoid. Okay, so area of a trapezoid, 1/2 height, b1 plus b2. So we're going to add the 2 bases. Multiply by the height. Again, this should be a 90 right there. I apologize, it wasn't. And we're going to multiply those together. So 13 plus 15 we'll add together first, times 10, divide by 2. We get 140 square units. Alright, this next one's more of an algebra problem here. It says find the height if you know the bases and the area. So we use the same formula from up here, so I'm actually going to kind of mirror it down here. So my area is now 126, I don't know the height, but I know the base. The bases are that. So we can actually use this to help us. So that becomes 28, and then half of 28, so we get 14 times h equals 126. And then we can go ahead and just divide by 14. We get h to be 9. Find the area of a rhombus whose perimeter is 40 centimeters and one diagonal is 8. Well, if you recall, a rhombus, all sides are equal. So if the perimeter is 40, that means all the sides are 10. And then what you also recall, these are right triangles. So one diagonal is 8. That means it's 4 and 4. So we have a right triangle. We can find the other one. So the area, if you recall, is 1/2 diagonal 1 times diagonal 2. So I got 8 there, but I don't know the other one. We can use Pythagorean theorem to find the other one. So we're going to get 4 squared plus x squared equals 10 squared. And to solve this, I'm just going to do it really fast. Okay. And let's see, it doesn't tell me how it wants the answer. So each side's about 9.2. We'll go with 9.2 for each side using Pythagorean theorem. And then all we have to do is go ahead and add those two together. So 9.2 added together gives us 18.4. And we can go ahead and multiply those in. Times 8, divide by 2, and we get 73.6. Okay, and that's area, so I apologize, but that should be square centimeters. Find the area of the rhombus shown below. This one's much easier. Not sure why they gave us a harder one than an easier one, but we can deal 10 and 14. So that's half of 140, I believe. We're just going to end up with 70 square units. That one's really easy. All right, find the area and circumference of a circle. So the area is pi r squared. Circumference is 2 pi r. Whose diameter is 24, so the radius is going to be 12. So the area is going to be 144 pi, because that's 12 squared. And circle is going to be, circumference, sorry, is going to be 24 pi. 12 times 2 are the diameter. All right, working our way through this. Volume is the area of the base times the height. So I'm going to choose this as my base piece. 3 times 9, then the height is 4. And we're going to get 108 cubic centimeters. Alright, this one's a tricky one for a lot of kids, but this is a right angle as well. Volume of the triangle prism, volume equals big B times H. Now the base is actually a triangle, so we're going to do 1/2 B times H. So 8 and 15 are my base and my height. And then the height of the prism is the distance between the two bases. So the two bases are actually this triangle and this triangle. See how they are parallel to each other? That's how we know that they're the bases. So the height is 19. So we got 8 times 15 divided by 2. So big B is 60 times 19, which is the height. And we get 1,140 cubic inches. Alright, find the volume of the cylinder. So this one's a little easier. The radius here is 5. So the volume of the cylinder is just pi r squared times the height. That's going to be 5 squared times 14. And leave it in terms of pi, so 350 pi. No units, so we're just going to go cubic units. Find the volume of the cone. So the cone is the same as the cylinder, except we're going to do 1/3 pi r squared times height. And we don't know the radius, so we're going to use Pythagorean theorem here, 40, 41, and x. We'll call it r. Why don't we call it r? And so that's 40 squared plus r squared equals 41 squared. And we're going to do this one real fast again. And square root. So you should actually get r equals 9. So you get 9 squared times not 41, but 40 is our actual height. Pi and 1/3. So multiply 9 squared times 40. So we get 1/3 pi 3,240. Divide that by 3, and we get 1,080 pi. Alright, a couple more and we're good. Volume of a pyramid. So this is again 1/3 the base times the height. Now the base figure is the 18 by 18, so we'll take care of that real quick. And the height is 20. That's how tall it is, and we do 1/3. So we just essentially multiply all these together and divide by 3 to get 2160 cubic centimeters. And sorry, you couldn't even see that. That was off the page. 2 more. Volume of a sphere. So volume of a sphere, if you remember, is 4/3 pi r cubed, which is pretty fun. And the diameter is 24, so the radius is 12. So 4/3 pi 12 cubed. So 12 raised to the 3rd power. Then I'm going to show you how to do this in the calculator. So we got that, and then I'm going to divide by 3, and then multiply by 4, and then leave that in terms of pi. 304 pi centimeters, and that's cubic centimeters. Alright, and last but not least, write down the scale ratios for scale factors, surface area, and volume. So a to b, a squared to b squared, a cubed to b cubed. Just like that. Alright, that's part 2. I will see you in part 3.